Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. Today, I will discuss the solution of a problem which I feel is difficult problem, and the problem is from the section Matrices and is related to the process of counting. And this question has appeared on 28th January 2025 in the morning shift. The given question is, let capital M denote the set of all real matrices of order 3 by 3. Let S be the set consisting of -3, -2, -1, 1 and 2. Let S1 be the set of all matrices from M which are symmetric. A is equal to A transpose and Aij belongs to S for all Ij. Let S2 be the set of all matrices coming from M which are skew-symmetric, that is A is equal to -A transpose and Aij belongs to S for all Ij. S3 is the set of all matrices coming from capital M such that A11 plus A22 plus A33 is equal to 0. That is, the trace of A is 0 and Aij belongs to S for all I, j. If n of number of elements present in S1 union S2 union S3 is 125 times alpha, then alpha equals. Let's now discuss the solution of the problem in detail. We are given S is equal to, let us call this S is equal to the set consisting of these 5 elements, -3, -2, -1, 1 and 2. Right? And how many elements are there? 5 elements. N of S is equal to 5. We are given M is the set of all 3 by 3 matrices whose entries Aij's are coming from S for all I, j. Right. Now let us take case 1. S1 is the set of all matrices from M which are symmetric. A is equal to A transpose and Aij belongs to S for all I, j. So S1 is the set of all 3 by 3 symmetric matrices with the entries coming from S. Right. So how the matrix of S1 will look like? It will look like A is equal to A11, A12, A13. Because it is symmetric, A21 is also A12, A31 is also A13 and A32 is A23. That means whatever elements that are present above the main diagonal, they will reflect the entries below the diagonal. So therefore, it is sufficient, we take such a situation. So now A11 and all these entries can take any element of S. So A11 has 5 choices, A22 has 5 choices, A33 has 5 choices. So also A12, A13 and A23. So that means you are filling up 6 places with 5 elements. Use the product rule of counting. How many elements are there in S1? So n of S1 will be 5 into 5 into 5 into 5 into 5 into 5. 6 positions, 6 places. That is 5 to the power of S. Agreed. That means so many symmetric matrices are there over S. Let's now take second case. S2 is a set of all those matrices A such that A is equal to minus A transpose. That means S2 is the set of 3 by 3 skew-symmetric matrices over S. For a skew-symmetric matrix, Aij is equal to minus Aj. So who are the entries of on the diagonal? So put I is equal to j. So Aii will be equal to minus Aii for all I. This will imply 2Aii is equal to 0 for all I. This will imply Aii is equal to 0 for all I. That means all the diagonal entries of a skew-symmetric matrix is 0. So the diagonal entries of a skew-symmetric matrix, they are all zeros. They are all zeros. So is the 0 element present in S? No. 0 was not there in S. Therefore, the number of elements S2 will be empty. Why? Because 0 does not belong to S. Therefore, n of S2 is 0. We continue the argument in the next slide. Right. Let's take the case 3. S3 is a set of all those matrices coming from M such that the trace of the matrix A is equal to 0. How many such matrices are there? That's the question. So you take the matrix A. First you talk about the main diagonal. I am not talking about the off-diagonal matrices. We are talking about the diagonal entries only. You know, A11, A22, A33 coming from S such that A11 plus A22 plus A33 is equal to 0. In how many ways this can be done? A11 plus A22 plus A33 is equal to 0 and Aii belongs to S can be chosen in the following ways. Let us say 1 plus 2 plus minus 3. The sum is 0. So they can be the entries on the main diagonal. So now, how many such permutations that you can think of? You can think of 1, 2, minus 3, 1, minus 3, 2, 2, 1, minus 3, 2, minus 3, 1, so on and so forth. So that means to consider all such permutations, 3 distinct elements are there. So the number of ways, number of permutations are 3 factorial, that is equal to 6. Is there any other combination? Yes, yes. We see 1, 1 minus 2. Yeah, 0. Now we have to consider all such permutations. How many such permutations will be there? Factorial 3 by 2 factorial. 2 factorial. Why 2 factorial in the denominator? So these 2 elements 1 and 1 are alike. Out of the 3 elements, 2 elements are alike. So the number of permutations will be 3 factorial by the number of alike permutations, that is alike elements, that is 2 factorial. So 3 factorial by 2 factorial is equal to 3. Right. So I can also think of 1 minus 1 plus minus 1 plus 2. Yeah, minus 1 is there, 2 is there. To consider all such permutations, in the above case, 3 factorial by 2 factorial, that's equal to 3, because minus 1, 2 elements are alike. So therefore, these are the number of ways of selecting the trace is equal to 0. Is there any other way? Is there any other choice? No other choice. Therefore, the total number of ways of selecting the trace is equal to 0 is 6 plus 3 plus 3, that is in 12 ways you can do it. for each way there are 6 off diagonal entries. Off diagonal entries means entries that are not on the diagonal. On the diagonal 3 elements are there, total 9 elements are there. So off diagonal elements will be 9 minus 3, that is called 6 elements. So these off diagonal elements can take any element of S. That means any element of the 5 elements. So each off diagonal element will take in 5 ways. There are 6 off diagonal elements, therefore that can be taken as 5 into 5 into 5, 6 times 5 to the power of 6 for each choice of the main diagonal. How many choices are there for the diagonal? 12. So the total number of elements in S3 will be 12 multiplied by 5 to the power of 6. You are using the product rule of counting. For each such selection, the 6 off diagonal entries can be chosen in 5 into 5 into 5 into 5, 5 to the power of 6. It is the product rule. And for each one, this one, the total will be, therefore n of S3 will be 12, the number of ways of selecting the diagonal, multiplied by 5 to the power of 6. You are using the product rule of counting. N of S3 is equal to this. So that now we are ready to count n of S1 union S2 union S3. Right. We have seen n of S1 is 5 to the power of 6, S2 is empty, n of S2 is 0, n of S3 is 12 into 5 to the power of 6. Now, S1 union S2 union S3 is equal to S1 union S3. Why? Because S2 is empty. And S1, now the problem reduces to n of S1 union S2 union S3 will be n of S1 union S3 only. What will be n of S1 union S3? N of S1 plus n of S3 plus n of S1 intersection S3 by the principle of inclusion and exclusion. So that's the reason why we are counting S1 intersection S3. So S1 means the entries, the matrices must be symmetric, and S3 means the trace must be 0. Both must satisfy because it is an intersection. It is an intersection. So this is how the matrices of S1 and intersection S3 will look like. So this is the one. The diagonal, the sum of the diagonal entries is 0, trace is 0, and the off diagonal elements they will reflect here because it is symmetric. You need not worry about this. So you have to worry about the off diagonal entries, just they are 3. So the diagonal entries can be chosen in 12 ways, which we have already seen. For each choice, you can select off diagonal entries 5 into 5 into 5, 5 cube. Therefore, the total number n of S1 union S1 intersection S3 will be 12 multiplied by 5 into 5 into 5. That is 12 into 5 cube. Right. We are ready. N of S1 union S2 union S3 is n of S1 union S3 because S2 is empty. And this is equal to n of S1 plus n of S3 minus n of S1 intersection S3 by the principle of inclusion and exclusion. Now we know n of S1, 5 to the power of 6, n of S3, 12 into 5 to the power of 6, n of S1 intersection S3 is 12 into 5 cube. Just substitute. Right. We have substituted. In all these things, you find a 5 cube common. 5 cube into 12 plus 1, 13 into 5 cube minus 12. This is given to be 125 times alpha, required to find the value of alpha. So alpha is equal to 5 cube into 13 into 5 cube minus 12 by 125. That is 13 this is 5 cube is 125. By 125 they cancel in the both numerator and denominator. You are left with 13 into 5 cube minus 12. 13 into 125 is 1625 minus 12. That will be 1613. So the value of the alpha is 1613. That is the answer to our question. This is 1613. It's a numerical answer type question. Therefore, you have to fill up the blank. The answer is 1613. That is the detailed discussion of the solution of the given problem. In my opinion, it takes a long time. Right. I will ask you to comment on certain questions that arise in the next slide. Yeah. Give your opinion. It's opinion only. It's your personal opinion on the following. So you have to answer the first one of the, in your opinion, one may be true out of the options 1 to 5. One is very easy. Second is not difficult. Third is difficult. Fourth is difficult. It takes long time to get the answer. Fifth is extremely difficult. Out of these 5, you have to choose, in your opinion, one of them. And the sixth one, you have to answer separate. Right? The sixth question is it justified to give such questions in the exam? Say yes or no for the sixth one. So, please give your opinion in the comments box for one of the 5 alternates that I have given, and in your opinion, what's the answer for this sixth one? Please give your opinion in the comments box. I expect that many of you will respond to this query and answer this one and write down in comments box. Write also in the comments box how the presentation and the explanation that I have provided for this question. Please comment. I am sure that you have understood the solution of this problem. I thank all of you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we are going to meet you once again on another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.